Hi everyone, Searing Frost here. Today we're going to dig into the Python grab bag and pull out decorators. Decorators are functions that take a function as a parameter and return a function. Python has special syntactic sugar for decorators using the @ symbol above function signatures. Multiple decorators can be used by separating them on multiple lines. Decorators are easier to understand with examples. We're going to build up a single decorator from simple to complex. This decorator is a basic function that takes a single parameter, f for function, prints decorated, and returns the function f. This is just a normal function. Python doesn't have any special syntax to define decorators. Let's define a function toDecorate that just prints toDecorate and returns 1. We can decorate our toDecorate function by placing @decorator above the function. When Python sees the @decorator, it actually immediately runs the function decorator with toDecorate passed as the first parameter. This is why decorated prints immediately. When we run our function, we can see the output toDecorate, but we don't see decorated print out. As mentioned before, this @ syntax is syntactic sugar for redefining toDecorate as the result of decorator with toDecorate passed as the only parameter. The result of this call is simply the function toDecorate returned from the decorator. What if we want to execute our decorator code when the decorated function is called, not immediately when it's decorated? This is where wrapper functions come in. Let's modify our decorator function. We can define a new function inside decorator called wrapper. This function will print decorated, then execute the decorated function f. Our decorator function now returns the wrapper function instead of our decorated function. Notice nothing is printed when decorated. And then when we run our newly decorated function, we get the output decorated and toDecorate. When we look at the equivalent syntax, decorator returns the function wrapper, but does not execute it. What if our decorated function takes parameters? How can we access them inside the decorator? Remember, we are calling the wrapper function when we call toDecorate, so if our function takes arguments, then wrapper can take arguments and pass them to our function when it calls it. Let's give wrapper a positional args tuple and a keyword args dictionary. Then we can just pass those parameters to f directly. Now we can modify our toDecorate function with some parameters, x, y, and keywords. And we will just print them unmodified. Now we can pass some random parameters to our decorated function, and we can see the results outputted correctly. This can be a little confusing, but remember, it's just a call to wrapper. Additional parameters can also be passed to the decorator function itself. We need a new pattern to accomplish this, the decorator factory. The syntactic sugar here is a little different. Decorator factories will be passed the arguments in the @decorator signature, then they will return a decorator. We can then access these arguments inside the decorator and wrapper functions. Let's just output the parameters so we can see how this works. We can pass in parameters to the decorator factory when we decorate our function, and they work just like normal function parameters. We can see the output is what we were hoping for. Breaking down the syntactic sugar, we can see that two separate function calls are made. The first call returns decorator from decorator factory, and the second call returns wrapper, just as before. Thanks for watching this tutorial on decorators. Decorators are a bit confusing when you first start working with them. Play around with the syntax and follow the chain of execution so you can understand what is happening. Decorators are used for tons of purposes. One of my favorite examples is the Tenacity library for retrying code after exceptions, which I have linked in the video description. Another common use case is a logging facility for logging decorated functions and their parameters automatically. Basically, anywhere you have generic behavior you want your functions to perform, a decorator could be a good choice. Links to my blog post on decorators and the video code are in the description. I'll see everyone next time.